Hello everyone, once again to Cambridge Guru channel. We were doing chapter number 10, which is vectors, and last video was about addition of two vectors. Next topic we are going to cover is angle between two vectors. So the figure shows two vectors OA and OB. In short, we can name these vectors as A and B. Means if I'm talking in terms of position vectors, so I will say position vector OA and OB, and simply I can name these as with the small letters A and B, right? And we have to find out the angle between these vectors A and B. Now, as you can see that if there are two given vectors, I can join the tip from the toe, or I can join both the tip of both the vectors. So the resultant will be AB. Okay, so here by joining the third side, I will get the complete triangle, and we have to find out this angle, right? So the technique we are going to use in finding out the angle is the dot product. We are not going to into detail that what do you mean by dot product, because that is part of physics. We are not going covering the physical aspect of dot product, but yes, we will derive that how the dot product gives you cos theta, or how cos theta comes in dot product. Okay, so since as you can see that there is a triangle ABC and there is an angle involved, and also this angle is included between these two sides, so I think this information is far, it's is enough to think that yes, I can apply here cosine rule. So if in any given triangle, if you know two sides and an angle, and third side also you can find out vector AB in terms of A and B by applying the triangular law of addition, right? That means you know all the three sides and you need to find out the angle. So cosine rule will be applicable, and I'm not talking cos theta of any right angle triangle. I'm talking about the cosine rule, which involves a square plus b square minus c square upon 2ab, right? So the same formula we will use, that what is cos theta in triangle, I can say in triangle A, B and O, or OAB, right? We have OA as a vector, OB as a vector, and AB as a vector, right? So cos theta I will write as OA square, right? And since I'm talking in terms of the side of a triangle, so basically I'm dealing with magnitude of vector OA, okay, plus OB. Okay, so these are the two sides which are containing this angle theta. So a square plus b square means magnitude of OA square plus magnitude of OB square, minus the third side, which is AB, so magnitude of AB square, divided by twice the multiplication of the sides which contain this angle theta. So again, OA vector mod into OB vector mod. Okay, so this is your cosine rule. Now, since the coordinates are given of the point A as A1 and A2, and for point B coordinates are B1 and B2, so I can find out vector OA is just A1, or directly I can find out the magnitude of this and then squaring this. So it is A1 means just find out the distance, applying the distance formula, it is A1 square plus A2 square. Okay, similarly OB magnitude square is B1 square plus B2 square. Okay, and lastly AB vector I can write as OB minus OA, right? OB minus OA, that means B1 minus A1 whole square. Remember the distance formula. If you know the two coordinates, you can find out the distance by subtracting the corresponding x and y coordinates. So I am just subtracting the coordinates B1 minus A1 whole square plus B2 minus A2 whole square, means x2 minus x1 and y2 minus y1 whole square. And since this is squaring, so I can remove the under root sign. Okay, in all these three magnitudes I have removed the under root sign because it is square, right? Now putting all these values in the above formula cos theta, so cos theta is a1 square plus a2 square plus b1 square plus b2 square minus this b1 minus a1 whole square, and with again negative sign b2 minus a2 whole square. You will say that why this is negative sign and here it is plus, because there is outside there is a negative sign. Okay, so if I introduce a bracket here, then there is a plus sign, right? Otherwise I can remove this bracket sign and write the negative here. So let us write negative. Okay, and in the denominator same thing is twice of OA mod of OA into mod of OB. Here I am not writing in terms of A1 or A2. Okay, that we can do later on. Now just simplify this. This is A1 square plus A2 square plus B1 square plus B2 square minus times again B1 square minus A1 square, and here I will get minus of twice A1 and B1, and minus is outside the bracket, so it will become twice A1 and B1. Similarly, in the second bracket you have minus B2 square minus A2 square but plus twice of A2 into B2, and in the denominator the same thing is there, twice of mod A into mod B. I'm writing not OA or OB, just writing mod A into mod B. Right, now see what terms get cancelled in the numerator. A1 cancel with this minus A1 square, A2 with this, B1 square with this B1, and B2 square with this. So in the numerator you get twice of A1 B1 plus twice of A2 B2, and in the denominator it is twice of A1 mod or mod B or mod A. Right, and here I can write this as by taking the common factor 2 from the numerator and cancelling this with this 2, you will get A1 B1 plus A2 B2 upon vector A mod into vector B mod. Right, so this is your cos theta. Right, now I can shift this A1 mod into B1 mod to RHS and write, let me choose another color, it is A1 B1 plus A2 B2 is equal to A mod B mod cos theta. Right, and if you have a knowledge of dot product, what do you mean by dot product is, let us say I have vector A as 2i cap plus 3j cap, and vector B is, let us say, minus I cap and plus 5j cap. Okay, and if I do the dot product mod A dot mod B, so this will give you a scalar quantity which is the multiplication of vector A with vector B. Right, so thing is that A coordinate will be multiplied by not A, the X coordinate will be multiplied by the X1, and Y not coordinate component, so X component will be multiplied by X plus Y component will be multiplied by Y. So 2 into minus 1 is minus 2 plus 3 into 5 is 15. So this gives you a scalar quantity which is 13, and I would say this is the scalar product or dot product of two vectors A and B. So okay, so here I have the vectors A1 and B1, not B1. A1 A2 means this vector OA and this vector is OB, and here I have A1 with B1. So A1 B1 means the corresponding X coordinates of point A and B are multiplied. Similarly, A2 B2 is the corresponding Y coordinates of this vector are multiplied. Of whose vector or which vectors? Vector OA and vector OB, not AB. Vector OA coordinates are A1 and A2. Multiplying this A1 with the corresponding X coordinate of OB, meaning that X coordinates are multiplied, plus A2 and B2 means Y coordinates are multiplied. So basically what I mean to say is that this is written as the dot product of two vectors, vector A and vector B, is equal to mod A mod B cos theta. Okay, so you will be given two vectors. What you need to find out is, separately you will find out this value of left hand side by using this technique, that multiplying the corresponding x and y coordinate and adding these two with sign, and separately you will find out mod A and mod B, and then find out the angle cosine theta, okay, by taking the inverse of this, right? So you can modify this, that cos theta is A dot B over mod A into mod B. This is cosine theta, and take the inverse of this, right? Let us take an example. Find the angle between these two given vectors. So you have been given a vector A, which is 3i cap plus 4j cap. There is no need to write the given vectors in component form. This is just to make you understand how the things are, right? So cosine theta is, so first find out the dot product. Dot A dot B is 3 will be multiplied by 5, which is 15, plus sine 4 will be multiplied by minus 12, means minus 48. Okay, so this value is minus 33. So this is your left hand side of the formula A dot B. Now find out the right hand side, that modulus of A is 3 square plus 4 square root, which is 5, and modulus B is 5 square plus 144 is 169 root, which is 30. Okay, so according to the formula, cos theta is A dot B over mod A into mod B. So A dot B is minus 33 divided by 5 into 13. Okay, so minus 33 over 65. Okay, that means theta is cos inverse minus 33 over 65. Now as you can see that this angle is not angle, but cos inverse value is negative. So if I look into the coordinates, where in the first coordinate all the trigonometric ratios are positive, but cos remains negative in second and in fourth quantity, or not quantity, fourth quadrant, right? So whenever there is cos inverse negative, so what you do is you just write down this as pi minus. Okay, to first find out the theta. I think this you have done in your AS level trigonometrics chapter, that first find out the principal value, which is this, let us say this is theta dash. So cos inverse 33 by 65 will give you some acute angle, but since this is negative, that means either it is in fourth quadrant or it is in second quadrant. As far as vectors are concerned, their angle is concerned, so either it is obtuse or acute. We do not give the you can say reflex angle. Okay, we keep the angles between 0 and 180 degrees, right? As you can see here, that if I'm talking about angle between two lines, let us consider the vectors as just lines. So there are two angles basically. So one angle is this, which is acute, okay, and another angle is obtuse. I can call this angle also alpha as an angle between two lines. So one is acute, one is obtuse, right? So this cos inverse is negative, that means it is an obtuse angle. Had it been just plus 33 by 65, we will go for cos inverse 33 by 65, which is an acute angle. But if this cos theta is coming out to be negative, that means angle is obtuse. Okay, and so this you can write as pi minus cos inverse with a positive sign 65. Okay, whatever is the value. Fine.